Assalamualaikum warahmatullahi wabarakatuh. I am ZOLFA JALIL. I want to introduce to you about our project. Our project is about automatic controller. Automatic controller is a device that compares the actual value of the output with the desired value. Automatic controller is the functions to determine the derivations of the signal of the system that produce the control signal that reduce the derivation to 0 and the small value. Okay, the basic controllation is as proportional controller, proportional integral controller, proportional derivative controller, and proportional integral derivative controller. In this project, we are using MATLAB software to design and to analyze our controller system performance. Thank you.
So I would like to present about the mathematical derivation of the system and how to analyze the stability of the system. Okay, so this is our mathematical model derivation of the system for the input and output variables. Okay, the value for the block diagram is already given in the equation. So for this block diagram contain resistive transducer coefficient, which is equal to 0.1 ohm. So the R total for this block diagram is 1 ohms for resistance and plus 0.1 ohm for resistive transducer coefficient, and equal to 1.1 ohms. So for this mathematical model derivation, we are using the formula of QLS over EQS equal to N1 over N2 time KT over SR time R plus LS time JEQS plus BEQ plus KT KB. And for formula for calculate JEQ is equal to J plus JL times N1 over N2 squared times S. And for calculate BEQ is equal to B plus BL times N1 over N2 squared. Okay, so after that we insert all the value that are already given. So after we calculate and solve it, we get the answer equal to 1 times 10 power of negative 6 over S times 0.5 times 10 power of negative 6 S squared plus 6.1 times 10 power of negative 6 S plus 1.11 times 10 power of negative 4. So after we get this answer, we will divide with 0.5 times 10 power of negative 6 because we want to get the simplest transfer function. So the final answer we get is 200 over S times S squared plus 12.2 S plus 222. So this is the final answer that we get for mathematical derivation of this system. Okay, so next we have to analyze the stability of this system. Okay, so to find the stability of this system, we using the Routh-Hurwitz stability criterion, which is firstly we need to find the characteristic equation by using the formula of Rs equal to Gs over 1 plus Gs Hs. Okay, so from this we will get the answer is 200 over S cube plus 12.2 S squared plus 222 S plus 200. So for the denominator, we take it as the characteristic equation. Okay, so from that we produced a table which is from S cube until S0. Okay, then from the table or array, we need to find the B1 and C1 value. Okay, to find the B1, we use the formula equal to negative 1 over an minus 1 in bracket an minus 1, an minus 2 and an minus 3. So after that, we insert all the value, and all the value that we take from the table, and we get the answer for B1 is 205 and 69. Okay, so for C1, we are using the formula negative 1 over B, bracket AN minus 1, B1, AN minus 3, B2. Okay, so after we insert the value, we get the answer C1 equal to 200. Okay, so after we get all the value, it shows that the first column have the same sign, and then all the root are in the left hand of the S-plane. Therefore, the system is stable.
FAUZI. Today our group would like to present about simulation on MATLAB, which is our final group project. Okay, so basically our project is free wheel gear. So we want to show the transfer function of the graph by using P controller, PI controller, PD controller, and PID controller. So let us take a look. Okay, so we have it. This is our MATLAB. This is the system of the rotating wheel. As you can see, this is a scope. This is step. If you click on it, it will show the step time, initial value, final value, sample time. For this case, I will take 1, and the final value is 1, so that the transfer function will on the y-axis will give the maximum value is 1. Okay. Now this is, we call it sum. If you want to find this, you can click on the library. Okay, so actually all of the tools in here, you can find it in the library. So if you want to create a system, you find it on the library and then you do it. Okay, so this is our transfer function. Okay, as you can see, this is our equation. We have calculated this. This is the numerator. Our denominator is based on this, s squared plus 12.2s plus 222. So for this, we take 1. Actually, this is 1s squared plus 12.2s. This is 12.2. Okay, and then this is 222. So absolute tolerance is auto, and then we click OK. Okay, this is the multiplexer. Okay, and this is the scope. It will show the transfer function graph. Okay, so let us take a look at this. This is our P controller. Okay, so for P controller, actually it the block diagram can set which one controller you want to create. For example, if I click on this, okay, you can choose at the icon here. This is PID controller, PI controller, PD controller, P controller. So on this case, we want to create a P controller. Okay, so we click OK. Okay, and then we run the simulation. Okay, run the simulation, and then we look at the transfer function graph. Okay, so as you can see, this is the transfer function graph of the P controller. Okay, so now let us take a look at PI controller. Okay, for PI controller, the transfer function graph is a bit different. Okay, so as you can see, we click on the simulation. Okay, and then we take a look at the graph. Okay, so it has overshoot. The transfer function is overshoot. Okay, so this is the shape of the graph. Okay, so let us take a look at PD controller. Okay, then we click OK, and then we simulate it and take a look at the graph. So as you can see, this is the graph, transfer function graph of the PD controller. Okay, so let us move on to the final controller, which is PID controller. Okay, so This is PID controller. Actually, this PID controller has a tune icon here. We don't need the tune icon because engineer have uh, uh, engineers said that this is less efficient than the real one. So if you want to use PID, you just click PID and then you click OK. Okay, and then you click on the scope. Okay, as we simulate it. Okay, as you can see, this is the transfer function of the PID graph. Okay, so that's all from me. Thank you very much.
Assalamualaikum. My name is AFIFAH JOHARI. My print number CE106144. I would like to present about the conclusion of this Pbl question. At the end of this project, we have successfully complete all the assignment given. Next, we also learn how to use MATLAB, in how to design the control system by using the simulink. We also learn how to tune the PID method by the simulink. In addition, we also have learned how to do the calculation by using MATLAB. The calculation is a transfer function. Transfer functions are frequently used block diagram represent of system. So that's all from me about the conclusion.